All right, guys, we're going to take a look at solving logarithmic equations, one of which we're going to need the properties of logarithms, and but both of which we can kind of do left, right, center after we figure out what's going on. Just like with exponential equations, you have to isolate your logarithm. So for number 15, the very first thing that I'm going to do is actually subtract 6 from both sides. Oops, that's minus 6 there. All right, so I have a negative 2 times a log base 9 of 1 minus x. What in the world? 1 minus x. Good grief. Sorry about that. Is negative 2. I'm going to divide both sides by negative 2 because I got that sitting out front. So let's write this a little bit neater. Log base 9 of 1 minus x equals that's divided by negative 2, equals a positive 1. And so then you can actually, if you want to, do left, right, center. You can also drop a 9 in the lower left-hand corner on both sides of your equation, which is using your inverse operations, but most of us, again, think about left, right, center. So 9 to the first power is 1 minus x. Okay, so then 9 to the first power is just 9. So I'm going to subtract 1 from both sides, so I have an 8 equals a negative x. So x equals a negative 8. And again, you should always go and plug, especially with logarithms, always go and take that answer and plug it back in and make sure that whatever, because remember, you cannot take the logarithm of a negative number, so you've got to make sure that that, sorry, is actually greater than 0 when you do that, okay? So let's go on to number 17. Number 17 does use a little bit of our properties, right? If I'm two logarithms that are the same base, and if I'm adding them, then basically whatever I've got, the x and the x minus 3, I'm actually going to multiply, and I will write them as one single logarithm. So I'm going to write log base 2 of x times x minus 3 equals 2. Okay? And of course, then you can go ahead from there to left, right, center. And so what you've got is 2 squared equals x times x minus 3. So 4 equals x squared minus 3x. I'm going to subtract 4 from both sides. So 0 equals x squared minus 3x minus a 4. I would factor that into 0 equals x plus 1 and x minus 4. From that, I'd set both of those equal to 0, and I get x equals a negative 1, negative 1, and x equals a positive 4. The problem is I cannot actually use this negative 1. Not going to work, because if I plug it back in right here, you cannot take log base 2 of negative 1, and you also here, you'd have negative 1 minus 3 would give you negative 4, not going to work, so you just get one answer, even though you had 2 to start with, only one of them works, so you do have to check that.